Hi, my name is Yasser Ibrahim, and I'm presenting the paper Methodology for Modeling Microclimate, Ladybug Tools, and ENVI Verification Study by Yasser Ibrahim, Dr. Tristan Kershaw, and Dr. Paul Shepard from the Department of Architecture and Civil Engineering, University of Bath, United Kingdom. As a rule of thumb, validation of computational models takes the shape of either validating against the real system field measurements, such as ENVI for outdoor microclimate simulation and Transys for building energy simulation, or verifying against the performance of valid models such as CitySim for urban energy modeling, which was verified against EnergyPlus. As a computational fluid dynamics model, ENVI is one of the most commonly used tools for modeling the microclimate. Nevertheless, people who are familiar with ENVI already know how excessively time-consuming it is to run an analysis, particularly when dealing with large-scale urban areas. So the aim of this paper is to present the Ladybug Tools microclimate model as an accurate and, most importantly, time-efficient method for modeling the microclimate compared to ENVI version 4.4.3. Methods of the study are the Ladybug Tools workflow, which includes a set of plugins used to connect Grasshopper with various software engines, such as the urban weather generator to account for the urban heat island effect by morphing the weather file, EnergyPlus to calculate the surface temperatures. OpenFOAM can be used to simulate the wind flow, although it increased the simulation time significantly. The amount of short-wave solar radiation and long-wave sky radiation absorbed by the human body is estimated by using the equations specified within the SolarCam model and the MinEx model, respectively. The different constituents are then combined into generic components to calculate different thermal comfort indices such as the physiological equivalent temperature, PET, or the Universal Thermal Climate Index, UTCI. ENVI, on the other hand, is a fully integrated model which accounts for all the heat exchange between surfaces, plants, soil, and the ambient air, and also produce a variety of thermal comfort indices. However, we had to use a student license in this study to be able to get the results in UTCI. The methodology of this study is based on assuring that the building geometry, materials, physical and thermal properties, and the boundary condition input to the Ladybug tools are as similar to those input to ENVI as possible. In terms of the boundary conditions, this was available by using the full forcing option in ENVI, which allows for importing all the weather data from a typical meteorological year file. So the three layouts shown here, linear, dotted, and courtyard, and their building constructions were defined in both models as similarly as possible and using a weather file for Cairo, Egypt as a representation for hot arid climate, which is the focus of my PhD. Simulations ran on the 7th of June, hottest day in the weather file, and from the sunrise until the sunset. Also, OpenFOAM CFD simulations were not included in the Ladybug Tools simulation since they increased the simulation time as mentioned earlier, and also without a noticeable effect on the results in our case. We compare the models in terms of the mean radiant temperature and the Universal Thermal Climate Index to represent the outdoor thermal comfort. Comparisons were made in 4 receptor points as shown above, and then the average for all the grid points over the layouts. Radiant temperatures maximum differences have reached 30 degrees Celsius in these extreme cases identified in red circles, while during the early and night hours just 12 degrees Celsius. Apart from these extremes, differences did not exceed 6 degrees Celsius. And also for the average values shown on the right side, the two models also had quite similar trends. The reason for these deviations were examined and a number of variations were highlighted. For instance, in terms of how each model processes the heat conduction, storage, and the amount of absorbed shortwave and longwave radiation. Most importantly, the reflected radiation in the Ladybug tools is defined with reference to the global horizontal radiation, which is confined to the diffused component during the solar beam obstruction. This was the reason for the sudden leaps and plummets, as in those cases shown. For the average UTCI values, as shown on the right side, maximum differences are around 6 degrees Celsius. The left figure shows the UTCI maps for the 3 layouts at 7 a.m., 12 p.m., and 5 p.m., which show minor variations. Also, we calculated the coefficient of determination R² between ENVI and the Ladybug tools, which has shown a positive correlation for both the MRT and the UTCI. In conclusion, with regards to the time consumed, which was nearly 95% faster using Ladybug tools than using ENVI in this case, and also would be around 60% faster for larger scale simulations. And in terms of the accuracy, which has reached around 93% for the UTCI, this study shows that the Ladybug tools model is more than accurate enough for optimization studies where hundreds or thousands of geometry configurations can be readily manipulated. Thank you very much for your attention, and if you want to get in touch with me to follow up with my findings, I'll be very happy to receive emails on this address, and for now I'll happily answer any questions.